Okay, here we are focusing on Chapter 6. We'll start with a brief review of what was covered about 2 weeks ago. Okay, so in section 6.1 of Chapter 6, we start looking at what a normal curve is and also a standard normal curve. So a normal curve has many characteristics, one of which is it is always symmetrical. Okay, so if you're looking at the screen here, you have two normal distribution, so the mean, mode, and median are all at the same place, and what you have on the right side of the mean, median, and mode is exactly what you have on the left side. We've also mentioned that in the normal distribution, the shape is always the same, but the mean can actually vary, and same thing for the standard deviation. Okay, and the comparison between the normal curve and the standard normal curve is for the second one, so the latter, the standard normal curve, the mean is always 0 and the standard deviation is always 1. So just for your information, what we're looking at right now is a normal curve and not a standard normal curve. Okay. One of the main problems that we dealt with last time that we covered Chapter 6 is problems such as this one here. So where you have or where you're asked to find a probability, proportions, or percentage. This was hard to understand for many students, so I decided to show you an example of what it would actually look like. So let's say we have a problem here. The marks of the test number 1 in QM are normally distributed with a mean of 78 and a standard deviation of 10. What is the probability that someone got 60 or less on test number 1? Okay, so this is a probability problem, the same kind of problem where I could ask you to find a proportion or a percentage. So how are we going to solve this problem? Okay, so here's our problem. We have a mean score of 78, so for test number 1, and a standard deviation of 10. Okay, so if we actually look at the normal distribution, it would look like this. So 78 in the middle, and then we can build our normal distribution this way with a certain number of standard deviation. Okay, so we have our normal distribution for our variable scores on test number 1. We are interested in finding what is the probability that one student will get a score of 60 or less. Okay, so the first thing that we will do is we can actually try to locate the score of 60 on the graph here. So really we want to estimate the probability or the proportion to the left, so this area of the curve. Okay, so what we are looking at right now is the normal distribution. We can also make this a standard normal distribution. So we know that the mean of this distribution will be 0 and the standard deviation will be 1. Okay, so on the same curve we have the standard normal distribution and the normal distribution. Okay, so how do we find how much the red area is worth? Okay, so the first thing that we need to do is we need to convert this into a z-score. So this is here the z-score formula. So you take your score minus the mean and you divide it by the standard deviation. Okay, so we have 60 minus 78 divided by 10. It gives us a z-score of minus 1.8. Okay, so if we look here at the blue values, minus 1.8 falls between minus 1 and minus 2, which seems to be accurate. Okay, so this is the first part. So the next thing that we need to do now, we have a z-score of minus 1.8, so we will come here and use the table. So I would like to draw your attention here, you have the z-scores, these are the decimal values. So minus 1.8, this would represent 0.0359, so 0.0359. Okay, so that's the z-score that we've identified with a score of 60. Okay, so basically what this tells us is that this area, the red area, has a probability of 0.0359, or we can write it as a percentage. So this area is worth 3.59% of the entire area. So what is the probability that a student will get a score of 60 or less? The probability is 0.0359, and that's how we would solve this problem. Okay, so in chapter 6.2, or section 6.2 of chapter 6, we also looked at other types of problems using the normal distribution, and it was problems where you have to find an actual score or an actual values. So problems could look like this. So if if you're looking at the same variable, so the test, the QM test number 1, if someone did worse than 20% of the students on test 1, what score did this person get? Okay, so if someone did worse than 20% of the students, what score would this person actually have gotten? Okay, so we are working with the same curve here because we have the same variable. But this time we're not interested in the area under the curve, but rather we are interested with an actual score. Okay, so we want to find the score that represents or that is worse than 20% of the other scores. Okay, so worse than 20%, we already know that worse than 20%, not better than, worse. So we are looking at this side of the distribution. Okay, so the first thing that we'll need to do before we can do anything with this graph is to actually find the area under the curve that this represents. Okay, so one thing that we need to keep in mind, worse than 20% of the other score, it's the same as saying better than 80%. If we're using the term better than 80%, all of a sudden we are dealing with this side of the distribution. Okay, so keep in mind this 80% because now we need to use the table to find the z-score equals to 80% of the distribution. Okay, so we have the same table as we were using before. And remember, now we have 80% in mind, or 0.8. Okay, 80% represents an area under the curve, not a z-score, an area. Okay, so if we're dealing with an area, we are looking at the values in the middle. Okay, and we'll use the middle of the table to help us identify an actual z-score. So very quickly, I will try to find 0.80 in this table. Okay, so 0.80, I have 0.7995, which is close enough. Okay, so this is the area under the curve that I want to find the z-score of. Okay, so that specific area here, what I can do is I looked at the value of 0.8, and if I scroll all the way up, you have 0.04. Okay, so this specific area of 80 would represent 0.84. 0.84. That's what we have here. Okay, so based on the table here, we found a z-score of 0.84. Okay, so that's an actual z-score. This is a score that we can locate using the blue value. Okay, so 0.84 would be before 1. So it would be around here. This value there, which we don't know what it is, we only know the z-score, represent a score that is worse than 20% of the other scores. Okay, so now we have located this on the actual graph. Okay, we go back now to our z-score formula. So we have z equals x minus the mean divided by my standard deviation. We know the z-score here, we have 0.84. We are interested in finding x. The mean of this distribution is 78, and the standard deviation is, we have 10 for standard deviation. This was given to us in the problem. Okay, so basically we need to isolate this value here. Okay, so in order to find x, what we would actually do, we would do 0.84 times 10, and we would add 78 to it, and we would actually find the value. So if we do this, 0.84 times 10 plus 78, we get an x. Okay, x would equal 86.4%, and that would be our final answer right here. Okay, in section 6.3 of chapter 6, we will start looking at what sampling distributions are, and I will cover this next time in class, but I just wanted to expose you to two different problems using sampling distribution. Okay, so let's look at one of the problem here, still looking at probability, proportions, or percentage. Okay, so a problem could be like this. The marks of test 1s are normally distributed with a mean of 78 and a standard deviation of 10, so same variable that we had before. What is the probability that a group of 30 students got a mean of 60 or less on test number 1. So not only one student, but a group of 30 students. Okay, so I will show you how to answer this problem. Okay, so for this problem, we're still working with a normal distribution. Okay, but this distribution is called a sampling distribution. This distribution has a mean of 78, just like our distributions of individuals or population, but the standard deviation for this distribution is a little different, is 1.8. Okay, so we can actually build our distribution here. So one standard deviation would be 79.8, then we would have 81.6, and we would have 83.4. On the other side, we would have 76.2, 74.4, and we would have 72.6. Okay, the standard normal curve is exactly the same mean and same standard deviation. This never changes. Okay, so we want to know actually the probability that a group of 30 students will get a score or a mean score of less than 60 comparing to this distribution here. Okay, so we do just like we did in the first problem. We actually compute the z-score. The z-score is equal, so you're taking the value from this distribution. So you compare the sample mean, okay, of your 30 students minus the mean of this distribution, which is actually 78, and you divide it by the standard deviation of this distribution. Okay, so standard deviation of this distribution, which is actually the 1.8 that we have here. Okay, so the z-score is equal to 60 minus 78, and you divide by 1.8. So the actual score that you get, the z-score that you get, is minus 10. Okay, so that's a z-score. Like we did before, we can try to draw it on the table, but as you can see, we don't see anywhere, we don't see 60 anywhere. The smallest value is 72.6, okay? So now to find the probability in the area, we need to use the value of 10, our z-score, and find the actual proportions or probability in the table. Okay, so this is our z-score table. If we actually look at this table, we're trying to find the area or probability for minus 10. Here we have minus 3.7 or less. Okay, so we have nothing close to minus 10. This is the closest that we get. So the probability to get that a group of 30 students will get an average of 60 or less for this specific variable is less than 0.0001. So very small probability. Okay, so another kind of problem, just like the previous example that we could get, but this time with sampling distribution, is if the Markov test ones are normally distributed with a mean of 78 and a standard deviation of 10, same variable, what sample mean corresponds to the 70th percentile? So 70th percentile. Okay, so let's look at how we would solve this problem. Okay, so this is the distribution that we have with a mean of 78 and a standard deviation of 1.8, the same as the previous one. And now we want to find an actual score. Okay, so the score of someone who scored in the 70th percentile. 70th percentile is the same as saying 70% of the scores were worse than yours. 30% of the scores were better. So 70%. Okay, so if we convert this, or if we want to answer this question, we first need to find a z-score. Okay, so we have an area under the curve equals to 70% or 0.7. So I'll use my table and find the z-score that equals to 0.7. Okay, so I'm looking for an area under the curve, so to the left of 0.7. So if I scroll all the way down and I looked here, so the closest to 0.7 that I get is actually this one right here. Okay, so this one right here. So this corresponds to a z-score of 0.52. So that's our z-score, 0.52. Okay, so in the table I got a z-score of 0.52. Okay, so if I locate it on my graph, 0.52 would be about halfway through here. So the score that I'm interested in is this one right here. Okay, so this score would represent the 70th percentile. Okay, so how do I do this? Same idea, using the z-score. The z-score formula, z equals x minus m divided by my standard deviation. And remember that we are working with the information from this distribution that we're looking at right now. So we have a z-score here of 0.52 equals to x minus the mean here 78, and our standard deviation is still 1.8. Okay, so if I isolate the x, I calculate it, and this will give me a value of 78.94, and that would actually be the score. So if you look there, it looks like this point here is around 78.94, so that would actually be the answer to our question.